agronomics in sediment and soils. Dr. Lucotte's team recently developed an analytical procedure that enables analysis of glyphosate and AMPA, which is a glyphosate degradation product, measurement of the efficiencies of riparian strips in reducing chemical fertilizer needs and pesticide leaching for soys and cornfields, and evaluation of alternative practices such as direct seeding, mulch-based cropping systems to reduce herbicide needs. Dr. Lucotte has been honored for his scientific and outreach accomplishments with several national and international prizes. Please join me in welcoming Dr. Marc Lucotte.
Bonjour, mesdames et messieurs. So don't worry, we'll not be presenting my talk in French, but I usually do in French. And when I talk about our project called the MyFrog project, I'm not sure my Quebec colleagues fully understand what it means. So you all here understand that us froggies, but we are working on glyphosate. So I will be presenting this glyphosate story and trying to be as I will not be exaggerating whatsoever, neither on one sense or on the other sense. I know that glyphosate is a very useful product, that most of you use it on a daily basis, on a yearly basis, and we'll just go and see what it does to your field. I have to say that our project is financed by the National Science and Engineering Research Council, so I'm not financed by Bayer, Monsanto, and whatsoever. I'm really financed in totally independent manner by the federal government. As you all know, there are many groups of herbicides, and the list is extremely long. You probably don't see anything. And one of them, number 9, the group number 9 is the group of glyphosate. But there's a whole lot of chemicals in your fields, as you know. Let's have a look at this famous glyphosate molecule. It's a very simple molecule. It's a molecule with nitrogen, phosphorus, and it's a linear molecule. It's not a cyclic molecule, so it's easily degradable. This very simple molecule is actually extremely potent to kill all plants. It was actually developed as an antibiotic, for those of you that maybe didn't know that, in the 1950s. This molecule has been around since the 1950s. It was commercialized under the name of Roundup in 1974. As you all know, it's a total, non-selective, affordable herbicide. And what really put glyphosate up front was that they developed genetically modified crops that were tolerant to this herbicide. And of course, it allows no-till agriculture. So far, so good. Glyphosate is a biodegradable molecule. So when Monsanto said that glyphosate doesn't stay in your soil, this is totally true. After 2 to 3 weeks in your soil, most of the glyphosate is gone. So it doesn't stay, even in Canadian perspective, in Canadian climate, this molecule is not stable. It is cut just about here by the bacteria that are found in agricultural soils. And what is very important, it makes a new molecule, a smaller molecule here, called AMPA. You had a problem to say this word, but if you really want to say the full word, it's Aminomethylphosphonic Acid. I will call it AMPA for the rest of my talk. This molecule here is very important because contrary to glyphosate here, it will stay in soils, and it will stay from 1 year to the next. This molecule also is a phytotoxin for plants. So it's a phytotoxin for soybean, it's a phytotoxin for corn, and so forth. So when you have a GMO plant, the plant were modified to actually tolerate glyphosate, but then when not modified to tolerate this new molecule. It's a byproduct of the main product. Interestingly enough, there's other ways to produce AMPA in agricultural soils. So you have this famous phosphate-free detergents, soaps, that we all use now that we are eco-persons, you know, and when you put those soaps in environment, they degrade, and they degrade exactly in the same molecules. So for those of you that are using the biosolids, the municipal biosolids in fields as fertilizers, maybe, not all the time, and we have to look at this very carefully, you may also add some AMPA to your soils. It's exactly the same molecule that you will find in soils. I will actually talk about this in a breakout session for those of you that are interested. Okay, let's have a look at the evolution of glyphosate in the world. It's an incredibly widely used herbicide. As you see, there is a 20-fold increase over the past 20 years in the world. It's used everywhere, in Argentina, in Brazil, in China, in Europe, etc. Even in Europe, if they don't use GMO plants, they will still use glyphosate to kill the weeds before they actually seed the crop. In Canada, the latest report in 2017, it's always taking a little bit of time to have those reports, 50,000 tons of active ingredient. I'm just talking about the active ingredient, not about the surfactant and all this stuff that they put also with the glyphosate. So it's a lot of glyphosate that we actually use all over the world. In Quebec, there was a very famous studies in 2015, and where the Ministry of Environment made an analysis of how frequent you could detect glyphosate and AMPA, the byproduct, in surface streams. And basically, in 91% of all the streams in Quebec, we detected glyphosate in 2015, and 77% of the cases we detected AMPA. The same person did another study, more recent studies, that was published last year, and it is getting even worse. You see that today we have almost 100% detection of glyphosate in water streams, in surface streams, I would say. And at the same time, interestingly enough, you have a decrease of the presence of other pesticides, and particularly so of dicamba and all this stuff. So glyphosate is not as toxic as other products, so it's a good for a bad thing here. It's a trade-off. In terms of concentrations, and then I will go to what you have in Ontario, but in Quebec, what we have today, you can see from the year 2000 to today, you have a real strong increase in the concentrations of glyphosate in the water streams, in surface streams. You all know that you have now glyphosate-resistant plants, quite a few. In Ontario, you have at least 4 of them that are just present all the time in your fields. So giant ragweed, fleabane, common ragweed, water hemp, etc. These plants are extremely difficult to get rid of. If you only use glyphosate, you will have to use other herbicides. Glyphosate also impacts the microfauna in the soils. So there's a very famous paper here. Glyphosate affects earthworms' activity, and this causes soils compaction. Now let's go to humans. Does it really harm human health or not? And this is a very big debate. I will not be able to make the right answer because, I mean, there are thousands of researchers around the world still debating about this. Basically, you have 2 divergent opinions. There's one opinion that was put up by the World Health Organization, the International Agency for Research on Cancer, and they declared in 2015 that glyphosate at environmental doses is potentially carcinogenic. It made a big fuss all around the world, when this report came out. Just about at the same time, another report came out, and it was put up by the European Food Safety Authority and US EPA. And this report said that there was no detectable effect. So why such divergent opinions? There's a very recent paper that that actually studied this meta-analysis that were put up, and they realized that the US EPA took into account an equal number of genotoxic studies on pure glyphosate, not the stuff with the surfactant and all the other products. And they also used independent and industrial researchers' results. So of course the industrial researchers, they're sort of more in favor of glyphosate. And basically it sort of made a little twist on this interpretation. On the other side, YARC only considered published studies on commercial formulations, so including the surfactant. US EPA only looked at the general public exposure through food consumption, whereas the YARC also considered occupational exposure, that is to say, all of you that are using sometimes glyphosate just to spread this herbicide in your fields. And in these cases, there may be some incidental exposure at higher doses. So I will not be able to answer the question. There are some divergent opinions about the danger, the carcinogenicity of glyphosate in the environment. Now let's look at the latest Canadian Food Inspection Agency report. All these products are Canadian produced, so it's not coming from China and other places in the world where they may use more herbicides than we do. And what you have here is on a total of 3,000 and something products actually grown in Canada, you have the number of products where they actually detected glyphosate in those products. And you see that in some cases it's quite high. For example, in grain product, they detected glyphosate in more than 1/3 of the product. For children's food, this was even more worrisome. You know, in about 1/3 of the product, they detected glyphosate residues. So if we stop at this column here, obviously there is a very large, very serious problem. And when you go to the next column, it was just because they made some toxicological studies on animals, and they looked at when the problems really started in animals, and then they translated these into humans, and they even divided by 100 the doses to make sure that this would be the what we call the lowest acceptable doses. So this is what you have actually. In Canadian product, there's only 4% of the grain product that are sort of concern. Luckily enough, for children's food, there is nothing, according to this translation from this column to the next here. So the status of glyphosate in the world. Europe is really a leader in that way. After months of very tedious negotiations, Europe reapproved the usage of glyphosate-based herbicides in 2017, but only for a period of 5 years. In 2022, they will have to get rid of glyphosate, but they don't know how they will replace glyphosate. And apparently, Bayer is working on new products and new herbicides, but I mean, this is an industrial secret, and we don't know exactly what's going to come up. In Canada, we did the same. We also reapproved the usage of glyphosate, but for a 15-year period. The Pest Management Regulatory Agency, this is an entity of Health Canada, reauthorized the usage of glyphosate-based herbicides in January 2019. And from this January 2020, then the non-governmental organization Safe Food Matters took action at the federal court against this Health Canada decision. So we don't know for how long we may continue to use glyphosate-based herbicides. Why am I able to talk to you today? It's just basically because very, very few people are able to measure glyphosate and AMPA in soils, in plants, in water. In our lab, it took us 3 years to be able to actually measure this product in all environmental compartments. So I will just go on the details here, but to tell you that what I will be presenting from now on is just results that we managed to get because we are able to measure glyphosate and AMPA in all environmental compartments. First thing we did, we looked at buffer strips just to see whether those buffer strips would help reduce the lixiviation, the weathering of glyphosate from the fields to the streams. In Quebec, we have a policy. It's not a law, it's a policy. I don't know in Ontario, but in Quebec, we should have 3 meters wide buffer strips along any streams, any ditches. And the study that we conducted using those willows and other grassy buffer strips, etc., it showed us that actually, unfortunately, none of the glyphosate, none of the AMPA was retained by those 3 meters wide buffer strips. This is unfortunate. I'm not saying that we should get rid of the buffer strips. I'm saying that 3 meters wide is not enough. It should be at least, be careful, at least 15 to 20 meters wide. I'm sure that you will be all very pleased if I took off 20 meters of your land, you know, on the side of each stream. Okay, let's have a look at the concentrations of glyphosate that we have in streams. So this is a very long here concentration line going from 1 to 1,000 microgram per liter. In Quebec, we are around 3 to 4 today, microgram per liter. In Ontario, you are around 15 to 20, so it's getting quite higher. In the US, they are around 200 microgram per liter of glyphosate on average. Up until 2011, there was a chronic aquatic toxicity that was put up at 75 microgram per liter. So it meant that basically in the US, they were far above this limit. And for some sort of very strange lobby pressures whatsoever from the manufacturers, this level was put up to 800 by the Canadian Council of Ministers of the Environment in 2012. And this is still what we have today in Canada. We went from 65 to 800. At the very same time, in Europe, they put down the limit at 0.1. So in Canada, we are at 800, in Europe, 0.1. So there's a tremendous difference across the size of the Atlantic here. In our group, we actually measured some toxic effects in the water, on plankton. We measured it at around 10 microgram per liter. So it is absolutely wrong to say that at 800 you only start to see the problems. It's at levels far below. So it means that in Quebec, in Ontario, we are quite in a range of starting to see the problems in streams, on plankton, not on humans necessarily, not on animals that will eat the corn or soybean. This is a study that we have been conducting in Quebec. This is why I usually give my talk in French, because we have a good relationship with all these farmers around the St. Lawrence lowlands. And I will be presenting a series of 2 campaigns that we did, one in 2014, and when we went back last year in 2019, just to see how the situation evolved during 5 years. This is a very complicated table. Basically, these are soybean producers, and these levels of glyphosate and AMPA have never been published elsewhere in Canada so far. So we are the first one to be able to present those glyphosate and AMPA levels in Canadian soils, in Quebec soils in that cases. These are soybean fields, and we have 3 types of cultivations: Roundup Ready, IP, and organic. And you have in spring, before sowing, and at harvest time. And what you see, first of all, is that, as we expected, the organic producers have very low levels of glyphosate and AMPA in their soils, but not 0. They do have some traces of glyphosate that we can measure. We may measure glyphosates and AMPA in their soils, even though they are organic. IP, or Roundup Ready producers, basically it's the same thing. There is no differences in terms of glyphosate and AMPA levels. So, is it a lot or not a lot? I will be showing this in a few minutes. In some cases, the levels are quite high, and especially for AMPA. As I told you from the very start, glyphosate is not a stable product in agricultural soils, in Canadian conditions. So glyphosate is being degraded in AMPA. And we can see this very well on this graph here, that you don't have so much glyphosate in the soils after a few weeks, but you do have AMPA. And obviously or somehow AMPA is accumulating in those soils. We found that there was more accumulation of this product when you have a lot of clay, so that is to say a lot of cations in those soils, and mainly magnesium, potassium, iron, calcium. And these soils with high levels of these cations were actually accumulating more glyphosate than others that were more sandy. Very complicated table, don't worry, I will not go through the whole table. This is the very new, you're the first one to actually see this, but we just put up this table for the conference. So this is the 2019 results as compared to what we had in 2014. So we went back to the same places and we measured again in soybean production, we measured the amount of the levels of glyphosate and AMPA that were in the soils. Organic producers, they still have glyphosate and AMPA in their soils. Not a lot, but at levels that we can not only detect, but even quantify. So we are looking at the sources of this AMPA mainly in the organic soils. In terms of AMPA, 5 years later in agricultural soils, it's still high. It is actually getting higher in about half of the cases. In half of the cases, we have more AMPA than we had in 2014. So it looks like we are accumulating slowly this product in soils. And what is totally new, and we were quite surprised because we didn't do that in 2014, we even measure now glyphosate and AMPA at 20 to 40 centimeters depth. And we found glyphosate and AMPA even at 20 and 40 centimeters depth. That is to say, much deeper than what you usually do with the tilling process. So there is somehow a weathering of this product at deeper horizons. Is this a lot or not? Should we worry or not about the presence of these chemicals in our soils? So let's have a comparison with what is happening in Europe. In Europe, they have far less glyphosate and AMPA than we do in Canada, about 5 times less. These are the levels that are given here. This is given for field crop production. But in Europe, if you go to vineyards, for example, you will have at least twice or 4 times more glyphosate and AMPA than we do in our agricultural soils. So in Europe, they use more glyphosate in vineyards, in orchards, than in any other type of production. So if we compare to what we have between Europe and here in Canada, we should worry if we are looking at the European situation. But if you look at the Argentina situation, there are very, very few studies published around the world regarding the presence of these chemicals in soils. Well, we are much better off. We have 2 to 4 times less glyphosate and AMPA in our soils than in Argentina. But in Argentina, they have 2 crops per year, sometimes 3. In Brazil, they have 3, twice soybean and once corn. So you may imagine how much glyphosate they put on their soils in 1 year. Our project, I will just finish with the presentation of what we actually do in our group, in the MyFrog project. We work at several places. We work at the Serum. Serum is the Grain Research Center. It's near Montreal. So we have experimental plots over there. And we do play with different doses of glyphosate. We do play with no-till or cover crops, no cover crops, etc., etc. And we look at the way glyphosate and AMPA are behaving in soils and how they interact with minerals. We also work with partners, farmers, and there's one of them that you all know here in this room. It's Mike Verdun, that I really do thank for the invitation to come and present our work at IFAO here today. And we have been following these fields for 4 years now, and also we have cover crops, no-till, different doses of glyphosates, etc., and we do follow what's happening in those soils for a couple of years. So what happens in those soils? This is not our study. This is a study that was already published before we started, but we do the same type of studies. When you do apply glyphosate-based herbicides, this has an impact, a very strong impact on nodulation of leguminosis. So you see here that the highest, this thing is, I think the battery is dead, but yeah, it's still here. So the highest glyphosate doses that you spread on the field, the least nitrogen accumulation or the least nodulation you actually see in leguminosis, in soybean or alfalfa or whatsoever. So this is what we actually work on. We work on the way plants are able to make the nodules with or without the presence of glyphosate and AMPA. Very important. You all heard about this chelation process of glyphosate for a whole bunch of minerals like manganese, calcium, potassium, etc., etc. What it does is just the shape of the molecule. You remember the shape of the molecule? So the molecule has this shape here. This is the molecule before it gets breakdown in AMPA. But this molecule here acts as a lobster claw, and the claw is able to keep these cations here blocked. So if you have calcium, if you have manganese, whatsoever, those elements, they're sort of trapped in the claw of glyphosate. And it makes those elements totally not bioavailable for plants. So plants suffer from the lack of these elements. They suffer from a lack of manganese, a lack of calcium, a lack of all these cations. So either you have enough cations in your soil for the plants to find the free ones and actually feed on them, or you have to add supplementary doses of cations to overpass this chelation process with glyphosate. When glyphosate gets broke down in a smaller molecule, in AMPA, it doesn't work as well, so the chelation is not as strong as it is with glyphosate, so it gets broken down here, but you still have a complexation between the cations and the AMPA molecule. So the cations are not fully bioavailable when you have the two products in the soils. And this is probably something that you will have to consider if you want to change the way you use glyphosate-based herbicides. So what it does, I'm pretty sure that most of you saw that already, is the more glyphosate that you apply, well, the least calcium, magnesium, potassium, etc., you actually absorb. So a very famous study here that was produced, that you see the result on the plant. The plant is actually getting weaker and weaker, yellow and yellow, just because you added more and more glyphosate, and glyphosate is actually chelating those nutrients in the soil. There's also another interaction with phosphorus. It's not a chelation interaction between phosphorus and glyphosate. It's just that phosphorus and glyphosate, they use the same sites of adsorption in soils. They get absorbed on clay or on organic matter exactly the same way. So by adding glyphosate in the soils, it removes the phosphorus. It makes the phosphorus more labile, and phosphorus may just leave the soil and actually enter the streams and go to eutrophication of streams, etc., etc. So it's just a question of replacing where phosphate normally is adsorbed in the soil. You replace it by glyphosate, and it removes the phosphorus. Okay, what can we do? Can we actually think about solutions? And this is important to say that we do work with repairists, that is over there at the first table. We will actually be presenting a breakout session. We work in several farmers' places to look at the interaction between glyphosate-based herbicides application and no-till and cover crops. And Louis will be much better off than I am to explain you the interactions between those cash crops and cover crops. And we do hope that by having all these cover crops, we may reduce the amount of glyphosate-based herbicides that we use. This is actually the way we try to work. using the cover crops as a way to reduce the amount of the doses of glyphosate-based herbicides. So these are a few pictures that I'm sure that we have many more pictures than I do to show you the interactions between cover crops and yields. Okay, just to finish up my talk, to tell you that we have, I have students working on processes, exactly what glyphosate does to plants, GMO plants, for example, to corn and soybean. The students is looking at stomata opening or closing. As you may know, the stomata of the plants, not only they allow this oxygen and CO2 transfer, but very importantly, they release the water from the plant. So when you have a stress, hydric stress, the plant should close the stomata, and when the plant would like to grow, the plant will have to open the stomata. An important element to actually do that, to help the plant to do this, is calcium. If calcium is available, the plant will be able to open and close stomata. So first of all, you remember there is a very strong interaction with glyphosate and calcium. So maybe calcium is not so available anymore for the plant to be able to perform this. But not only this, when you apply glyphosate-based herbicides, you all witness this yellow flashing on the plant. What is this? It's because the plant, even if it's GMO, the plant suffers for a few days. And when the plant suffers, what it does, it ventilates, it opens the stomata. It opens the stomata at the very wrong time. It opens the stomata in a full day, when the plant should actually close the stomata to reduce evapotranspiration. So my student is actually working on this double effect of using glyphosate-based herbicides and at the same time having this hydric stress on the plants. Very interesting that these cover crops, no-till and cover crops, they do play a very positive role on stomata. You have here a picture, electronic microscope picture. You have the stomata here, these are the little dots here, and you see the same plant, this is soybean, no-till plus cover crop, same scale, and you see that the stomata for the no-till plus cover crop here, the stomata are much bigger, they are less stomata, but are much bigger, and they work much better. So they resist the hydric stress, even though you apply glyphosate-based herbicides. So this is quite interesting, a very interesting opening to actually advocate for the usage of cover crops, no-till plus cover crops. The plant does have a better metabolism along with this. Okay, so this is basically what I wanted to tell you. There will be 2 breakout sessions where I can interact with you and answer your questions more at ease. So you understand that we are not working against the farmers, we are working with the farmers, trying to find solutions to reduce the usage of glyphosate while maintaining high yields. I am not against chemistry. I always say that when you get sick, we don't like to use antibiotics. None of us like to use antibiotics. But if you really get pneumonia or something like this, you will be quite glad to actually be able to use antibiotics. So let's try to use glyphosate in a safer way with smaller doses and eventually get rid of this dependency that we all have on this chemical. So thank you very much. I think we have a few minutes for questions.
I do have a question that's come in. If there's any more, put your hands up and we'll get them up to the front. So the first question I have, Marc, is I read that AMPA degrades over time to P and formaldehyde. Is this true? And if so, what are the potential effects and over what time period?
Okay. This is a good question. There is very little work actually done on AMPA. Why so? Because very, very few laboratories around the world are able to measure this product. So very, very little is known about the residence time of AMPA in agricultural soil. Of what we see, and this will be one of the openings we can do in breakout sessions, what we can see is that from one year to the next, AMPA is basically staying. It doesn't degrade over the fall and over the winter. In the spring, somehow AMPA is getting degraded. The smallest product that AMPA can give is just phosphate, because there is phosphorus atom in the AMPA molecule, and the smallest part of AMPA is just phosphate. So it actually enriches the soil. But to go to that point, it takes time. It takes at least 1 year, and I suspect it takes 2 to 3 years to completely get rid of AMPA. This may be one of the reasons why we still find AMPA in organic soils. And it may stay quite a few years in the soil, even if you went organic.
Okay, another question here for you, Marc. What is a biological process that converts glyphosate into AMPA, and could it be mitigated? Would this decrease the overall environmental toxicity?
Again, this is a very difficult question. It's very difficult to answer because we don't know very much about these very intricate processes happening in the soils. Definitely bacteria, fungi, they do play a role, but how do they degrade this molecule? How do they act exactly? It is not known yet. So what we see today is just the result, how long the product stays in the soil. I can tell you that glyphosate is only staying 2 to 3 weeks under regular temperature and water conditions. But the rest is really difficult to answer.
Thank you. Regarding the buffer strips for reducing glyphosate in streams, what type of field management was used? Example, no-till tillage, things like that.
If I knew, I would be able to tell you, just do no-till and cover crops, etc. I hoped, actually, I can present some of our results in the breakout sessions. I hoped when we initially started this project with Louis and Mike and others, we did hope that this no-till and cover crops would help actually degrade glyphosate and AMPA more readily. It doesn't seem to be the case. Actually, it seems to be even worse. That is to say, if you have cover plants, you have a larger accumulation of AMPA and glyphosate in the soils. It seems as if you have no cover plants, glyphosate and AMPA are just released directly to the streams, but they are not degraded. If you have cover plants, the degradation is not happening, but they're staying in the soil.
Where you measured higher AMPA levels, did you ask about biosolids use? And a general question, are biosolids used in Quebec?
Okay, so we do have a project right now, I have to say. It is not financed yet, but we do hope that it will be financed with Englobe. So I'm quite transparent about this. And we will actually measure the amount of AMPA that is present in the biosolids that we are currently using in Quebec. We do not use the biosolids from large cities. We don't use the biosolids from Montreal, for example. We use biosolids from smaller municipalities where there's not so much industrial activity and so forth. And I will be very glad in a few years to come back here and to tell you, how much AMPA is there in those biosolids that Quebec producers use. There are other studies, I will be presenting this in the breakout sessions. In Europe, for example, in some cases, biosolids can double the amount of AMPA you have in soils as compared to what is being produced by the degradation of glyphosate. In other cases, it's minor. But in some cases, really, it's like adding twice as much AMPA in your soil just because you're using municipal biosolids.
Okay. The last question I have, and I apologize if I don't pronounce this one word right, but does AMPA block the shikimite pathway? Did I say that right?
Shikimate, yeah. The shikimate, yeah.
Does glyphosate block that pathway? AMPA. Sorry.
AMPA.
Sorry.
No. Okay. Glyphosate blocks the shikimate pathway, that's for sure. This is why it was actually put up, created. But AMPA doesn't block the shikimate pathway. the phytotoxicity is completely different. Actually, I don't exactly know how it works, but it's not the Shikimate pathway. It's really the glyphosate that blocks the Shikimate pathway.
Thank you very much. I appreciate a couple of things. I appreciate when we have speakers speaking in their non-native language and then answering questions that way. Merci beaucoup.
Merci. Okay.
Dr. Marc's done something else for us too. He's